Okay, in this presentation we are going to look at confidence intervals. This is a worked example and it relates to proportions, as a proportion based on a single sample. So let's read the question. A press release for a broadband provider stated that 90% of the customers are satisfied with the standard of the service. However, to test this claim, the local Chamber of Commerce surveyed 110 randomly selected customers, and of that 110 randomly selected customers, 89% stated that they were very satisfied. Now, there's three parts of this question, but really ultimately goes towards the one particular conclusion, the one particular procedure. Calculate the appropriate value for the standard error for the confidence interval, and then calculate the 95% confidence interval for pi, the true proportion. What is your conclusion for this claim about 90% made by the press release? Justify your answer. Okay, so let's look at the general structure of a confidence interval. Hopefully you're fairly familiar with this. So a point estimate plus or minus the quantile that is drawn from either the standard normal distribution or the student t distribution, this quantile here, and the standard error. So we have three calculations, or three numbers to get ready: the point estimate, the quantile, and the standard error. And we piece them all together, and that will help us develop our confidence interval. The point estimate is straightforward enough. That is essentially the sample proportion. In this case, the sample proportion is 89 divided by 110, and we could denote that as p hat, which is 0.81. Now, in this particular example, we're dealing with a large sample. N equals 110. Okay, so for 95% quantile, that is 1.96. Okay, now if you're not familiar with where that comes from, I'm not going to sort of talk about it in this video, but surely after a while you will hopefully get familiar with the fact that for a 95% confidence interval, when you're dealing with a large sample, the quantile is 1.96. Okay, so we're just going to sort of take that as the number we're using, and if you're not sure where it comes from, I think actually we'll have to just work on that separately. Okay, now this is the key part here. The standard error for the proportion. Okay, so we have p hat here times 1 minus p hat divided by n. Okay, now p hat is the sample proportion. Now, just as a quick remark, when we are working with confidence intervals, this is the format of the standard error that we should be using. If you're doing hypothesis tests, there's actually a different procedure, a different sort of formulation of the standard error, and you will be working on that accordingly. Okay, so there we go. The standard error of p hat equals the square root of p hat times 1 minus p hat divided by n. So that is the square root of 0.81, which is our estimate from here, times the complement of that, 0.19, divided by n, which is 110. Work that out, we should get the square root of 0.001411, and when we get the square root of that number, it should work out to be 0.0374. Okay, now when you're dealing with confidence intervals of proportions, that looks right. Let's put it that way. So the margin of error is what we get when we multiply the quantile by the standard error. Okay, 1.96 times 0.07345. Just as a quick remark, this collectively is the margin of error, this part here. Okay, that combined expression, the product of those two numbers, the margin of error. So plus or minus this margin of error, the point estimate plus or minus the margin of error. Okay, so it's minus 0.81 plus or minus 0.07345, and there we get 0.7356 and 0.8825. Okay, so that actually is the answer to the second part, with this being the answer to the first part. Now, just the third part actually asks us what is our conclusion based on the assertion made in the press release. Okay, this 90% of the customers. Okay, so this confidence interval tells us at a 95% level of confidence that the true proportion is between 0.735 and 0.88. Okay, 0.90 is not in that confidence interval. Okay, so essentially that the claim that this broadband company is making cannot be supported by the evidence from this study. Okay, they don't have enough evidence to back it up, or even another way of looking at it is the evidence provided by the study contradicts that claim. Okay, remember, it's about evidence, strength of evidence. It's not about whether it's true or false. Hypothesis testing and confidence intervals are really about the strength of evidence. Okay, so we'll leave it there.